Hello everyone! In this video, we are going to solve a third-order differential equation using the Laplace transform. The given equation is y triple prime plus y double prime plus 2y prime plus 2y is equals to e raised to negative t, with the initial conditions of y of 0 is equals to 0, y prime of 0 is equals to 1, y double prime of 0 is equals to 0. Before solving, let's recall the Laplace transform of derivatives. The Laplace transform of y prime is equals to sy minus y of 0. The Laplace transform of y double prime is equals to s squared y minus sy of 0 minus y prime of 0. The Laplace transform of y triple prime is s cubed y minus s squared y of 0 minus sy prime of 0 minus y double prime of 0. Now, apply the Laplace transform to the entire equation. Laplace of y triple prime plus Laplace of y double prime plus 2 Laplace of y prime plus 2 Laplace of y is equals to e raised to negative t. By combining it and applying the initial condition, you can get the s cubed y minus s plus s squared y minus 1 plus 2sy plus 2y is equals to 1 all over s plus 1. Since they are all in terms of y, ilalabas natin ang y. Y, parenthesis, s cubed plus s squared plus 2s plus 2 minus s plus 1 is equals to 1 all over s plus 1. And then, isolate the s plus 1 into the right side of the equation. Y times s cubed plus s squared plus 2s plus 2 is equals to 1 all over s plus 1 plus s plus 1. And then, combine. Equals to 1 plus parenthesis s plus 1 close parenthesis squared all over s plus 1. The s plus 1 squared equals to s squared plus 2s plus 1 equals to 1 plus s squared plus 2s plus 1 equals to s squared plus 2s plus. The new form of the equation is y is equals to s squared plus 2s plus 2 all over s plus 1 times s cubed plus s squared plus 2s plus 2. Factor out the denominator. S cubed plus s squared plus 2s plus 2 is equals to s squared times s plus 1 plus 2 times s plus 1. S cubed plus s squared plus 2s plus 2 is equals to s plus 1 times s squared plus 2. The final equation is y is equals to s squared plus 2s plus 2 all over s plus 1 squared times s squared plus 2. Now, let's take the partial fraction of the equation. S squared plus 2s plus 2 all over s plus 1 squared times s squared plus 2 is equals to parentheses a all over s plus 1 plus b all over parentheses s plus 1 squared plus cs plus d all over s squared plus 2 parentheses. And then multiply it by their denominator s plus 1 and s plus 1 squared and s squared plus 2. S squared plus 2s plus 2 is equals to a times s plus 1 times s squared plus 2 plus b times s squared plus 2 plus cs plus d times s plus 1 squared. Now, let's expand each terms. As cubed plus as squared plus 2as plus 2a plus bs squared plus 2b plus c times s cubed plus 2s squared plus s plus d times s squared plus 2 squared plus 1 is equals to as cubed plus as squared plus 2as plus 2a plus 2bs squared plus 2b plus cs cubed plus 2cs squared plus cs plus ds squared plus 2ds plus d. Now, let's make a working equation to solve the values for a, b, c, and d. In terms of s cubed, 0 is equals to a plus c, equation 1. In, in terms of s squared, 1 is equals to a plus b plus 2c, equation 2. In terms of s, 2 is equals to 2a plus c plus 2d, equation 3. For the constant, 2 is equals to 2a plus 2b plus d, equation number 4. From equation 1, c is equals to negative a, equation 1 prime. Substitute equation 1 prime to the equation 2, 3, and 4. For equation number 2, a plus b plus 2 times negative a plus d is equals to 1. Negative a plus b plus d is equals to 1. Equation 2 prime. For the equation number 3, 2a plus negative a plus 2d is equals to 2. A plus 2d is equals to 2. Equation 3 prime. For equation number 4, 2a plus 2b plus d is equals to 2. Equation 4 prime. From equation 3 prime, A is equals to 2 minus 2D. Equation number 5. Substitute 5 to equation 2 prime. Negative 2 minus 2D plus B plus D is equals to 1. B plus 3D is equals to 3. Equation number 6. Substitute the equation number 5 to 4 prime. 2 times 2 minus 2D plus 2B plus D is equals to 2. 2 times B minus 3D minus 2, equation number 7. Solve for the value of B. B plus 3D is equals to 3 plus 2B minus 3D is equals to negative 2. Cancel 3D both sides. So the remaining one is 3B is equals to 1. The value of B is 1/3. Now substitute the value of B in getting the value of D. 1/3 plus 3D is equals to 3. Now, the value of D is equals to 8 over 9. Solve for the value of A. A is equals to 2 minus 2D. A is equals to 2 minus 2 times 8 all over 9. Therefore, the value of A is negative 2 all over 9. But A is equals to negative C. Therefore, the value of C is 2 all over 9. Y is equals to the 2 over 9 over S plus 1 plus 1/3 all over S plus 1 squared plus negative 2 all over 9S plus 8 all over 9 over S squared plus 2. Now, let's take the inverse Laplace to get the final answer. Inverse Laplace of 2 all over 9 over S plus 1 plus inverse Laplace of 1/3 all over S plus 1 squared plus inverse Laplace of negative 2 all over 9S plus 8 all over 9 all over S squared plus 2.
The final answer is 2 all over 9 e raised to negative t plus 1/3 t e raised to negative t minus 2 all over 9 cosine of square root of 2t plus 8 all over 9 square root of 2 sine 2t.